Jai Hind dosto, this is Prajesh and welcome to AirPra once again. Today's topic that we are going to explore is the detonation mechanism and warhead know-how. I have divided this topic into two parts. The first part will cover contact fuses, proximity fuses and fragmentation in weaponry. In the second part, we will delve into the latest generation of warheads equipped with modern weapons. So let's dive into the detonation mechanism first, alright? In 21st century warfare, the design parameters of all weaponry have changed drastically. Striving for the best detonation mechanism and warhead design is a constant effort in explosive technology. A contact fuse is a crucial component of explosive ordnance designed to detonate upon physical contact with a hard target. It is also known as an impact fuse. It consists of a sensor mechanism usually located at the nose of the munition that detects impact or pressure changes upon striking a surface. Upon contact, the sensor triggers an explosive reaction within the warhead, causing it to detonate. Contact fuses are employed in various military applications, including artillery shells, bombs, and anti-tank munitions, where precise timing of detonation upon impact is essential for mission success. Typically, fuses for airdrop bombs have relied on an internally positioned inertia fuse activated by the abrupt deceleration upon impact. The contact fuse mechanism ensures that the fuse is only capable of activation after intentional bomb release. Here are some examples of airdrop bombs that utilize contact fuse mechanism, such as GBU-12 Paveway 2 laser-guided bomb. This precision-guided munition employs a contact fuse mechanism in conjunction with its laser guidance systems. Second one is the JDAM kits that are added to regular unguided bombs like the Mark 82 or Mark 84 to turn them into precise guided munitions by incorporating contact fuse mechanisms. Contact fuses come in different designs tailored to specific requirements, with features such as delay options to optimize effectiveness against different types of targets, making them a critical component of modern munitions system. For example, in this video clip, you can see that the warhead explodes after the first few layers of penetration. This means the warhead did not penetrate as soon as it was impacted. Time delay fuses are designed to detonate the bomb after a predetermined amount of time has passed since release. For example, GBU-57A or B Massive Ordnance Penetrator is a precision-guided 30,000-pound bunker buster bomb used by the United States Air Force, utilizing contact fuse with a time delay mechanism. Well, there is a link in the description below if you want to read the complete article on airpra.com. A proximity fuse, also known as a variable time fuse, is a sophisticated electronic device utilized in explosive ordnance to trigger detonation when it approaches within a certain distance of its target. Unlike contact fuses, which rely on physical impact, proximity fuses utilize sensors such as radar, laser, or infrared to detect the target's proximity. When the target reaches a predetermined distance from the munition, the fuse initiates the explosive reaction within the warhead, resulting in detonation. This sophisticated trigger mechanism may increase lethality by 5 to 10 times compared to the common contact fuse. In some cases, it is also equipped with a calculated delay proximity fuse such as the Aster 15 and Aster 30, which is a Franco-Italian family of all-weather vertical launch surface-to-air missile. However, for example, in this video clip, you can see that the warhead of this unidentified missile explodes with a delayed proximity fuse. Proximity fuses are critical in anti-aircraft artillery, missiles, and air defense systems, enabling accurate targeting of aerial threats without requiring direct contact. They provide enhanced effectiveness by increasing the probability of hitting fast-moving or maneuvering targets. Proximity fuses utilize various sensor types to detect the presence of a target. Some common sensor types in the 21st century include radar or radio sensors. These sensors emit radio waves and detect the reflected signals to determine the distance and velocity of the target. Radio proximity fuses are effective against a wide range of targets, including aircraft, missiles, and projectiles. For example, Indian origin Astra air-to-air missile utilizes radio proximity fuse. Infrared IR sensors detect the heat emitted by objects and are particularly effective against heat-producing targets such as aircraft's engines or missiles. They can operate in both passive and active modes, making them versatile for different engagement scenarios. For example, American origin Sidewinder air-to-air missile utilizes infrared proximity fuse. The third one is laser sensors. Laser proximity fuses work by sending out laser beams and measuring how long it takes for them to bounce back from the target. They are known for their accuracy and are often used in guided missiles to make sure they hit the target exactly. Some modern air-to-air missiles like the ASRAAM and AA-12 Adder use lasers to set off the explosion. Another one is acoustic sensors. Acoustic proximity fuses detect the sound waves generated by the target's engines or other moving parts. They are suitable for use against helicopters and other aerial platforms. Manpads like the Igla incorporate acoustic proximity fuse or grazing fuse, you can say, in their missiles. These fuses enable the missile to detonate when it detects the distinctive acoustic signature of an aircraft or helicopter, ensuring effective engagement of airborne targets. Fragmentation weaponry encompasses a category of weapons crafted to cause harm across a broad area by dispersing shrapnel or fragments upon detonation. These arms typically consist of explosive devices like grenades, mines, or artillery shells engineered to break into numerous small pieces upon explosion. Preformed fragments available in shapes such as spheres, cubes, and rods. Those are typically securely contained within a matrix or a body until the high explosive filling detonates. The primary aim of fragmentation weaponry is to inflict damage on personnel and equipment within a specified radius. The effectiveness of fragmentation weaponry lies in its ability to create a lethal cloud of high-velocity shrapnels, which can penetrate armor and cause devastating injuries to unprotected individuals. These weapons are particularly effective in open terrain or environments where the dispersal of shrapnel can maximize casualties and disrupt enemy forces. Here are some examples of fragmentation weaponry. First, I can say fragmentation grenades are hand-thrown explosive devices designed to disperse shrapnel upon detonation. Second one is artillery shells. Fragmentation artillery shells such as high explosive fragmentation, in short HE frag shells, are munitions fired from artillery cannons. And the third, I can say cluster bombs. Cluster bombs are airdrop munitions designed to disperse smaller bomblets or sub-munitions over a wide area. Another example of a recent weapon is the Rampage, an advanced air-to-surface missile developed by Israeli Military Industries (IMI) that combines radio proximity and blast fragmentation detonation mechanism for precision targeting. Its radio proximity fuse triggers detonation at a set distance from the target, increasing lethality. Meanwhile, its blast fragmentation capability disperses high-velocity fragments over a wide area and can cause significant damage to enemy personnel and equipment. Well, this is all about some of the detonation mechanisms and examples of fragmentation weaponry being showcased here in approximately like 10-12 minutes. However, it is the first part, as I mentioned earlier. I hope you have understood the importance of detonation in weaponry overall. So in the second part, we will delve into different types of warheads, okay? And please do not forget to hit the like and subscribe, and also write your comments about what you'd like to see in the next video. So take care, stay curious, and see you in the second part exclusively for you, okay? Bye-bye.